Up to this point, we've have taken equations and we've graphed them. For example, on the left in the pink there, I have the equation y equals 2x plus 3. And if you were asked to graph this equation, we made this x and y table, and then we graphed the line from those points that we got from this x and y table. Now, the topic of this section is actually writing the equation of a line. And this is a pretty heavy algebra topic because it's used so much in future types of algebra classes that you might have. Let's take this equation in the pink and let's just review this quickly. So in other words, I have y equals 2x plus 3. Now I'm going to substitute numbers in for x, multiply them by 2, and then add 3 to figure out what y is. So I'm going to substitute 0 in for x. So let's see, 2 times 0 is 0, and 0 plus 3 is 3. So y would be equal to 3. So one ordered pair I have is 0, 3. Now to graph that, remember the first number is how far left or right you move. The second number is how far up and down you move. So I'm going to start at the origin. I'm not going to move left or right because it's 0, but I'm going to go up 3. So 1, 2, 3, and I put a dot or a point at 3 on the y-axis. Now let's find two more ordered pairs. I'll put 1 in for x. So 2 times 1 is 2, and 2 plus 3 is 5. So y would be equal to 5. So another ordered pair is 1, 5. So now I'm going to start at the origin again. I'm going to move right 1 and then up 5. 1, 2, 3, 4, 5. So it'd be about right there. And finally, I'm going to use a negative number. So I'll substitute a negative 1 in for x. So 2 times a negative 1 is a negative 2. And a negative 2 plus 3 is 1, a positive 1. So another ordered pair would be a negative 1, 1. So to graph that, I would start at the origin again, move left 1, and then up 1. Now my coordinate plane here isn't exact because I just kind of sketched it, but you can see that these points would more or less lie in a straight line, and then you'd be able to draw a straight line through this. And this would be what this line for this equation would look like. And finally, we would label it y equals 2x plus 3. Now, if we kept on doing equations this way, we would find that there's a relationship among this and this. So in other words, the number in front of the x and then the number that's at the end. And in fact, any equation that's written in this form has a special relationship with how we graph them, and that's kind of what we're getting into. So let's take a look at this special form, and this would be something that you want to make note of. So this special form, y equals mx plus b, is called slope intercept form. So let's make sure you label that. So slope intercept form. And this form has these characteristics. Y is always equal to something. So in other words, y is, we've solved it or isolated the y variable, and y is equal to some number times x, and we'll call that number m, plus some other number b. Now, I'm going to concentrate on this screen on the b part of it. All right, and that's not a 6, it's a b. Now the b part of it is what we call the y-intercept. And as I go through this presentation, this will make more and more sense. So that plus something or that minus something is called the y-intercept. And what's it mean? What's the word intercept mean? Well, it means to intersect. And it's going to intersect the y-axis. So for example, if I had an equation y equals some number times x, say 2x, plus 3. Well, the b part of this, or the number at the end, is the y-intercept. So all this is saying is that this line is going to cross the y-axis, right, the y-intercept at a positive 3, because plus 3 means a positive 3. So whatever this equation looks like, it's going to cross the y-axis at a positive 3. That line will pass through right here on the y-axis. Now another example is if I had y equals a negative, say, 2/3 x minus 4. What's the y-intercept in this equation? Well, it's a minus 4. It's a negative 4. So if I were to graph this equation, it will pass through the y-axis at a negative 4. So 1, 2, 3, 4. It would pass through the y-axis right there. And that's what we mean by y-intercept. I'm going to do one more. Say I had y equals 3x plus 5. Okay, what's the y-intercept in this one? Well, it's a positive 5. So this line would pass through the y-axis at 5. 1, 2, 3, 4, about right up there. Okay, y-intercept. So whenever an equation is written in this form, which we call the slope-intercept form, that plus something or minus something at the end, or we refer to it as the b, is the y-intercept. Alright, so we know b is the y-intercept. Okay, so I'm going to label that. So the b part, or that plus or minus something, is called the y-intercept. And that is where where the line is going to cross the y-axis. Now the next part, this m, whatever number or fraction or decimal is in front or is the coefficient of x, the m is referred to as the slope. And what does slope mean? Slope is simply how steep our line is. Now, if m has a positive slope, and this is something else you want to make note of, if the slope, if m is positive, that means the line is going to rise as we move left to right. So I'm going to, on my left coordinate plane, I'm going to show lines that have a positive slope. So, for example, if I graphed a line and say it looked like this, that's a positive slope, because as we move from left to right across the coordinate plane, notice the line rises. It's going up. Another line that would have a positive slope might look like this, because as I move from left to right, the line's rising. So if the slope is positive, if the number right here is a positive value, it's going to have a positive slope. The line's going to rise as you move left to right. Another example would be something like that. Now, what do you think happens if the slope is negative? Well, the line's going to fall or decline as you move left to right. So some examples of some lines that would fall as you move left to right would be something like this. So this line falls as I move from left to right. It's declining. Or another example would be this line. It's falling. It's declining. It's going down, if you want to phrase it that way. So if the slope is negative, if this number right in front of the x is negative, that means we have a negative slope. So two things that you want to make note of. What does a positive slope look like? What does a negative slope look like? Now, so far then, we know that b, the b part, is the y-intercept, and I'm going to abbreviate that, the y-intercept. So far, what do we know about the number in front of the x? Well, we know that if the slope is positive, the line's going to rise as you move left to right. If the slope is negative, it's going to fall or drop as you move left to right. Now, there's one other thing that we need to know about slope, and it's this. Make note of this. Slope, how do we determine slope? Well, slope is simply rise over run, or in other words, the change in y over the change of x. And it sounds difficult, but you know what? It really isn't. Now, let me give you an example. How about if we know that the slope, or the number in front of x, is a negative 1/2. Say I know that the slope is a negative 1/2. Now, since the slope is negative, I know the line's going to fall as we move left to right. Now, how can I determine slope? Now, here's an example. This is where we're going to try to put all this together. If I have the equation y equals a negative 1/2 x plus 3. Now notice my slope is a negative 1/2, just like I have there. Where can I start? Well, I know that the y-intercept crosses. Where does this line cross the y-axis? Positive 3, right? So I'm going to put a dot at a positive 3 on the y-axis. So 1, 2, 3, right there. And that's kind of a starting point for me. Now, here's how I use slope to determine or to get some really easy points for the rest of my line. Well, I know the line's going to fall, right? And I know that slope is equal to rise over run. So, the top number is how far up or down I move, which is the y. And the bottom number, the run, is how far left or right I move. So, what I'm going to do here is I'm going to go, I could, from this point that I graphed on the y-axis, I could go down 1 and then right 2. So it'd be about right there. And why did I go down 1 and not up 1? Well, because I know my line is going to fall as I move to left or right. Now, you know what? I could have went from this point right here, I could have went up 1 and then left 2. And no matter how I do that, if I do it correctly, I'm going to get points that lie in a straight line. So now from this point right here, I could go down 1, right 2 again, so about right there. Or up here, I could go up 1 and left 2, so about right there. The main thing I'm trying to show you is that top number is how far up or down you move. The bottom number is how far left or right you move. And that's something that you want to take note of. Now, the best way to put all this together is to actually go through some examples. So let's take a look at example 1. I have the equation y equals a negative 2/3 x plus 2. Is this equation in slope-intercept form? Is it in this form where I have some number times x plus some number? And the answer for that is yes. So I know that this line, I start with the y-intercept. Okay, my line is going to cross the y-axis at a positive 2. So I put a point at a positive 2 on the y-axis. Okay, so far so good. Now my slope is negative, isn't it? The number, which is right here, the number in front of x is negative. So what's that mean? As I move from left to right, my line is going to fall or drop or decline, however you want to word it. Now, since I got to keep that in mind, my line is going to fall. It's not going to rise. Now, what's my rise over run? Well, let's see, 2/3. This is the rise over the run. So 2, the top number is how far up or down I move, and the bottom number is how far left or right I move, the run from left to right. So I start at my point over here, and say I went up 2. So I'll go up 2. Now, in order for the line to fall, I got to make sure I move left 3. So I'm going to go up 2 from this point, and then left 3, so about right there. Okay? Or, from this point, I could go down 2, and then which way? Well, I'd have to go right 3 in order for this line to keep on falling. Now, from this point again, I could go down 2, right 3, and I could keep on doing that until I get a number of points. And if I do it right, these points are going to lie in a straight line. And this is a really easy way to graph an equation.